Hello, my name is Uchenna Asogwa, and I'm a chemical engineering graduate student at the University of Toledo. I am working on an engineering education research related to YouTube problems. Today's episode is about one of the three strategies that we use to measure the effectiveness of students reading YouTube problems. In other videos, we discussed students' perception of problem difficulty using the NASA TLX survey and quantifying problem solving with the process rubric. Our focus today will be on how to measure students' learning attitudes with class. So what is class? Class is an acronym for the Colorado Learning Attitudes About Science Survey. The class is available for different science courses: biology, physics, math, and chemistry. Before now, there is no engineering-specific version available. So as part of our research project, sponsored by the National Science Foundation, we modified the class for physics survey by directing questions towards learning engineering. This class survey consisted of 42 question statements with 4 multiple choice options: strongly agree, agree, disagree to strongly disagree. For instance, one statement says, to learn engineering, I only need to memorize solutions to the sample problems. An expert response would be to disagree or strongly disagree. Students agreeing with expert response score 1, while those disagreeing score 0. Across 42 statements, the expert responses varies randomly between agree and disagree. To ease analysis, we collapse strongly agree and agree as one choice, and similarly, strongly disagree and disagree as one. So scoring class is based off expert beliefs on 42 questions and how choices align with those of experts, and this is expressed as percentages. We can now look at how students align with desired attitudes towards learning engineering early in the semester before solving YouTube problems and near the end of the semester after solving YouTube problems. And this is important to understand whether or not solving YouTube problems influence students' learning attitudes either in a positive or negative way. Our findings show positive median attitudes sitting around 80% in alignment with desired attitudes throughout the duration of the semester. Statements in class are grouped into various categories representing various attitudes as they relate to different aspects of learning. While many studies have categorized class, here is a brief grouping shown by K. Douglas. In this case, class is grouped into 3 broad aspects: personal application and relation to real world, problem solving and learning, efforts and sense making. So the numbers in parentheses represent the number of statements that make up each of these groups. For a group like personal application and relation to real world, there are 6 class statements that make up this group. We can look at each of these categories based on a pre and post comparison, and that will give us an in-depth information of which different aspects of learning attitudes is impacted by YouTube problems and which is even impacted the most. We have quantified changes in attitudes using normalized gains, and we can see an overall 15% gain in learning attitudes. We also measured the most improvements in attitudes related to personal application and relation to real world, followed by problem solving and learning, then efforts and sense making. And this is where we come to an end on today's episode. Thank you for watching this video. Our videos about problem solving and problem difficulty can round out your knowledge related to measuring the usefulness of YouTube problems.